Okay. Tuesday, June 19th, 2 weeks from yesterday. That's when the exam is. I will tell you right off the bat, I'm very concerned about that date. Monday, I believe it's the 11th, is the last time I'm going to see you in a classroom setting where you're required to be here. That test is 8 days later. That concerns me a little bit that I don't see you and this is your last exam, but you guys are going to have to figure out on your own a way to study and time management wise. When do you study for your science stuff, your language, English if you have it, and then math at the end. Okay, so that does concern me slightly. It's in Gym A, 8 to 11 o'clock. I will let you know I'm not going to be here before to answer last minute questions. All right, I will show you my review times in a second here, but that time before the exam, that morning, 7 o'clock, 7:30, I will not be available. And it's going to be in Gym A. I'll get your seat number later on in the week. All right, I don't have it right now. I'll get it later on in the week. Here's everything you need to bring. Very similar to the midterm. You can read it for yourself. Here's my deal, my compromise. If you need to borrow any of these things, you have to come to a review session. If you need to, because I see some people taking calculators every once in a while. If you need a graphing calculator for the exam, you got to come to the review session. You get the calculator then. And you have to stay for a little bit at the review session. So that's my give and take. You need a compass, same thing. All right, you got to come to a review session though. I am not going to bring any of these to the exam other than no excuses. All right, I am not going to bring any of these to the exam. Okay, so night before, Monday night, make sure you got everything maybe in a Ziploc bag. Okay, check, got the pens, pencils, straight edge, etc. Got it all with me ready to go for this last exam. All right, questions about that at all? Questions about that? We're all good there? Okay, do me a favor, please. Please, if you have your Chromebooks, take them out, get to our class webpage on Aspen, please. If you don't, it's not a big deal. I'll display it up here. Okay, so under our class webpage, we have the Regents review folder. So just open that up if you have your Chromebooks. You will see a ton of stuff underneath. First one right underneath is construction videos. All right. If you open up that folder, there is a link that you can access that will cover every single construction we've done this year. All right. Because I'm going to be honest with you guys. I don't think I'm going to have much time in class to go over the constructions. There's other things I'm more concerned with, and the constructions, as you know, take about 5 to 10 minutes. All right, so I'm not saying waste. It's not a waste of time to go over one, but when you guys have a link and it goes step by step how to do the actual constructions for all we've done this year, I think you'd be better utilizing that one. All right. Also, there's any type you guys see the chains there, little chain links. All right, that is a website it'll bring you to. This one right here, you don't need to click on it. I'll just click on it. These are 2 extra online tests that I'm not going to give you. All right, I'm not going to print out for you. It's actually pretty decent. Here they are. You can do a part 1 and a part 2, 3, 4, 2 different tests. You can literally sit with your notebook in front of you, jot down your work and your answers, click on what button you think is the answer, and at the end, it'll score it for you. You can check your answers and it'll score it. Okay, so those are 2 extra online ones if you choose to do that. Next one here, review times. Here are my Regents review times. I'm going to email this to all of you and your parents next period. All right, so everyone is aware. You can thank me later for that. All right, starting this Friday, there's going to be late buses. Same thing with Monday. There's going to be late buses if you want to stay after and review with me. Just some ones of note. These are all during finals week. Okay, I'll be up in my room during that time if you want to come in. Saturday before the exam, I'll be here as well, 12 to 2:30 up in my room. And then I may regret this, but I'm going to be here Monday night before the test, 5:30 to 7:30 up here. Okay, and then the test is that Tuesday, and we grade it the day after. All right, so I will send a copy to all of your Bethlehem schools email and to your parents as well next period with this review schedule attached to it. Okay, and it's on Aspen if you don't usually check your email. Okay, and by the way, I counted up 14 and a half hours. All right, so I don't know how much more time I can dedicate there. All right, 14 and a half hours of review if you take advantage of it or not. Review times. Remember back in February, I had you guys do questions. There was 315 of them, and I had signed a couple a night, and I got rid of that because people weren't doing that. We remember that whole Deal? Well, here are the same questions, but if you go at the end now, all the answers are attached to them now. Okay, so there's 315 questions here if you want to try some out. Okay, and then the answers are attached here. Okay, and then let's see, what else do I have? And then your checklist is on here that I just showed you guys, and you guys have it right in front of you. And then finally, you guys, I'm hoping, are going to be checking your homework answers on JMAP. And the guy puts the work on there, which is fine, but I get it. Sometimes you guys are like, well, that still doesn't help me out. What work he wrote down for that question. So what I found was a different website, if you're interested, where not only do they have the answers, but they have video solutions to it. Takes a second. Yes. Any Regents exam, geometry Regents exam that's out there, they will have video solutions now to it. Maybe. This took a while. Second period. But yeah, maybe it'll come up, maybe it won't. You can go on whatever exam you're on. It'll say video solutions for numbers 1 through 12, video solutions 12 through 24. You can click on it. Guy's a little corny, but it'll pop up and it'll explain the topic and how he got the answer. Okay, instead of just seeing somebody's work written down, that may be better for some of you. All right, so that's another website that you can go to for all the solutions, because I'm not going to post any. There's no need for me to post them when they're out on the web somewhere. Okay, so a lot of different resources for you guys to try. Questions about any of them? We all good? I really don't want to keep reminding you every day. I just want to jump right into it starting tomorrow. No questions, comments? I'll have your seat numbers later on in the week. All right? Okay, good deal. All done with that now. Keep going. All right, so now I'm just going to turn my attention to the homework you guys had, 2 through 16 even, and a couple part 2, 3s, or 4s. And I understand the answers are out there. That's why I'm not going to post them. But if you guys just want to circle answers and write down what that guy wrote down, hey, you can get your 3 points, but you guys know what's at the end of the tunnel here with the Regents exam. And I will let you know, out of the 3 Regents exams, the Algebra 1, the Geometry, and the Algebra 2, the curve is very little help of the Geometry one. Okay, the curve probably just boosted you right up last year, made you feel great. The Geometry one is not as convenient. It's probably out of the 3, the least one that helps you out the most. Okay, so just keep that in mind as you're preparing. Yeah, 2 through 16 even, and a couple of the part 2, 3s, 4s. Like I said, here we go. I'll open it up. I have certain questions I want to do with you today, but I'll open it up to you. And if not, I don't get a lot of questions. What I'm going to do is, okay, I'm going to pick this question. How'd you do it? That's the way I'm going to go here. All right, if that's the way I got to get people to start doing questions, then that's the way I'm going to do it. Go ahead, Emily, start us off. Okay, 31, everybody. That was in the part 2 section. Yep. One of these guaranteed, I can't say guaranteed because I have no idea what's going to be on the test, but it seems like this comes up every year where you need the radius and the center of a circle, but the circle is not into our equation that we're used to, which is x minus h squared plus y minus k squared equals r squared. Okay? Just not in that format. But we need to get into that format, and if you remember the circle unit, the way we do it is by a method called completing the square from Algebra 1. Okay? I'll turn it over to you guys. I'll start probably asking individual people tomorrow, but I'll just talk to you guys as a group here. First step I have to do. Group up the x's, group up the y's, get that single number over to the other side. All right, so I need the x squared to be paired with the negative 6x. I need the y squared to be paired with the 8y, but I got to move it over by adding it. And that 56 can stay right where it is. Okay, all the x's and y's are groups. Now you're going to complete the square twice. Once for the x's, once for the y's. Anybody remember how to get that new c value that I'm going to add to the x's? And separately, I'm going to add to the y's. Go ahead, Nick. What do you got?
You divide b by 2 and
Take half your b value in each case. Take half your b value in each case, divide it by 2, and square that number. Don't yell it out. Just think about it in your mind. Half of -6, then square it. What's my new c value for the x's? Go ahead. What do we have? 9. And half of 8, square it. Think about it in your head. What's my new c value for my y's? 16. Here's a step we always forget. Just keep it in the back of your mind. Whatever you add to the left, you have to add to the right. And what I mean by that is I don't just move the 9 and the 16 over. No. Keep them there. Keep them there. You just add 9 to this side, add 16 to that side to balance it out. Questions on finding that c value? Now, finish completing the square. Now make it look like your circle equation. I'm asking you to factor it, but I'm just going to show you a trick quick trick to factor it so you don't have to worry about it. What was half our b value? Well, easy. Sign goes with it. X minus 3. That's half the b value. What was half our b value over here? Y plus 4. That is half your battle right now. The second half of the battle, getting the center and the radius length out of that now. Center, and you can make it easy on yourself. It's the opposite of what's inside here. It's the opposite. So my center is going to be +3, -4. And remember what this number represents. It's not your radius length. It's your radius length squared. So what number did I square to get 81? 9. All right. Amy. Okay, everyone go to 10 on your August 2017 one. Okay, here we go. 10. We got a line transformed by a dilation centered at the origin. All right, dilation. Anytime I dilate a line, what happens to it? It stays what with the original line? Parallel to the original line. All right, anytime I dilate a line, doesn't matter where I dilate. It could be origin or the random point I dilated around. Lines stay parallel when I dilate. And I mention this because that's exactly how I'm going to do this problem, because I'm going to find the what of this line. Slope, and what do I know about slopes and parallel lines? They are the same, all right? Slopes are equal here. That's what I'm going to find. Because I'm dilating, I know, okay, lines are parallel, so their slope should be equal. What do you want to do to solve for y on this one? Divide by 4. I'm doing this the long way. I know there's a quicker way you could do it. You could just look at it and move the 3x over instead, but I'm going to do this the long way. 3/4 x plus 7/4. What's the slope of that line? 3/4. So I need to go to my multiple choices right now and find out what else has a slope of 3/4. All right, so if you go through the choices, what else would have a slope of 3/4 when I moved everything over? Well, let's see here. How would I move that 3 over? Subtract it, and then how would I move that 4 over? Well, guys, easy. Move the 3 over by subtracting. Now, how do you move the 4? And what's going to end up being the slope of that one? Positive 3/4. Yep. Okay, so when you dilate, lines stay parallel. All right, lines stay parallel. Well, let's go. Okay, 26. Looks like we're going to part 2. Or is it the last one in, nope, part 2. Okay, got to remember our properties here. Here we go. Properties of a rhombus. This will lead us to the final answer, which is what's the perimeter? They give us information about the 2 diagonals of the rhombus. All right, here we go. Properties of rhombus diagonals. Bisect each other because it's a parallelogram. So I automatically know PR, which is 16, is going to be cut into 8 and 8. And I know this 30 of SQ is going to be cut into 15 and 15. That still is not going to help me out. I got one more property, Amy. Perpendicular. They are congruent in a rectangle. Congruent in a rectangle. Perpendicular in a rhombus. Knowing that they form a right angle, how can you find one of the sides? Pythag. And if you know one of the sides, what's an additional property of a rhombus? All sides congruent. So I can multiply it by 4. Correct. So I would have 1, 1, 1, 1, and then these pair here would be congruent. Thank you for reminding me of that. Diagonals do bisect the angles they're drawn to. So 8 squared plus 15 squared equals your side squared. And I believe your side came out to be 17. So my perimeter, 17 times 4 congruent sides, 68, no units. Luke.
12.
Okay, 12, everyone. Let's go. Circle, yep. Not our strongest unit, so I'm just going to review as much circle stuff as I can in class. And I'm glad you asked this because this leads me to the other handout that I had given you today. We got a tangent PA and a secant PBC. PB at length of 3, BC at length of 15. What's the length of PA? Okay, so now, from now on, you're sitting at home or wherever you end up doing your practice problems, and you're like, I think I remember the way to do this, maybe, maybe not. As you came in today, you also have a little study guide from me, which has facts, the no down cold. This is basically a, I don't know how many pages it is, maybe 5-6 page summary of the 40 weeks we've been together. Okay, including, if you keep scrolling through, I believe it's kind of in the middle, it looks like, all the circle facts. Okay, all the circle facts. So if you get stuck and you're like, whew, I want to try to do this one on my own and not ask me tomorrow, here you go. Here's all the circle facts. So let's take a look real quick if we can find the one we need here. If you guys look on the left-hand side there, everyone see a secant and a tangent drawn in somewhere on this right-hand side. Everyone see it? And then there's the saying of what we had, which was whole times external equals whole times external. Okay? Tangent, what do you know about the whole and the external part? They're always the same. So tangent is just going to be x squared. We said whole, not part times part, whole thing. So what's the whole secant length? 18 times its external part. 3. X squared equals 54. You never know what the directions are going to be 2 weeks from yesterday. May say simplest radical form. I don't know. In this case, because it's multiple choice, do you need the ability to do that? No. Everyone's going to have a calculator at the exam, right? You can do square root of 54, and then, I know it's not 3 or 4 now, and then find out which decimal is equal to square root of 54. Is it 3 radical 5 or 3 radical 6? We're not doing that, though, because we're preparing you for any scenario. Biggest perfect square that goes into 54. Perfect square. 9 times 6. Anybody square root of 9? Just 3, and then that square root of 6 comes along for the ride, and that's why it's going to be choice 2. Okay, so if you get stuck anywhere, a formula that's not on the formula sheet, take a look through your study guide here. Take a look through your study guide. properties of quadrilaterals, just like that rhombus question. I don't know every single rhombus property. Okay, here you go. Go to your study guide. It's in there. Okay, all the properties of a rhombus. All right. Next up, anything else before I go to my questions for the day here? Anything else? So are we very clear on where I can check our answers from now on for homework? Either you can still go to JMAP, or you can click on the website I gave you on Aspen where it goes video solutions, whatever you prefer. All right? Yes, Luke. Yep.
So in two, they're both dilations. How
Okay, and yep. Based on the scale factor. Where I just lost. Oh, it's right in front of me. Okay, so two real quick. Both of them are dilations. You are correct. This one's a dilation of scale factor of 1, which means it doesn't go anywhere. It stays right where it is. Here, though, it's a dilation of 3/2. So it's getting 1.5 times further away from the point. Here, because it's a scale factor of 1, it's not moving anywhere. It's staying right where it is. Okay? Anything else? Good questions here today. All right, I've tried to pick the hardest ones I could find. I'm not going to shy away from them. All right, I want you to be prepared for everything. First one I'm going over today is number 30 with you. Number 30. I'll let you guys read through it. We'll talk it over together. Some of you guys may already know what's going on, but we'll talk it over together. Okay, you ready? I see some people already marking. Perfect. Determine and state if BC and YZ are congruent. So first thing is we got to agree yes or no if they are, and then why. What's happening to ABC to XYZ? I don't know what it is, rotation, translation, I don't know, but at least I know it's a what? Sequence of rigid motions. And what do I know about rigid motions? Preserve side. Preserve side. So what do I know about AC and W and XZ? They're congruent. What do I know about C and Z? Boom. And what do I know about A and X? Also congruent because these are rigid motions and I know they preserve the angles and the side lengths. A and X. Okay, I haven't written anything down yet. I want to talk about it with you. What do I know about the triangles? Why? Angle, side, angle. Why would BC be congruent to YZ? Now we just got to write it down. It's basically a little proof, isn't it? Except we don't have to go statements, reasons. We can just write it out. All right, so you guys told me AC, and this is not exactly how it needs to be written down. There's a lot of flexibility here. AC was congruent to XZ. You told me angle C was congruent to angle Z. And angle A congruent to X. Why? Because rigid motions there you go, preserve angle measure and side length. Okay, that's how you knew all three of those were congruent. Then you told me what about the triangles? Triangle ABC congruent to triangle XYZ because of angle, side, angle. Should we put a thus in there like the old days? Therefore, henceforth. Therefore, BC congruent to YZ because of CPCTC. There you go, guys. Nice job. All because you knew what a rigid motion was, something that does not change size or angle measure. I heard it said, I think I heard somebody say it, and it's going to be incorrect. You cannot just go to say the triangles are congruent because rigid motions do this. What it said, it doesn't say the triangles were moved by a rigid motion. It just says the angles in that side are. Okay, so you cannot say the triangles are congruent by it because it's a rigid motion. All right, the triangle it did not. The directions did not say the triangles were moved by a rigid motion. It just says those two angles in the sides are. All good. Keep grinding. Oh, Sue, number 25. She thinks those two cylinders have the same volume. We got to say yay or nay on that one, and why. Are those two cylinders have the same volume? Formula sheet, if you need it, attached to this exam in the back. This is the way we're going to approach this. We're just going to find the volume of the both of them, and okay, that's fine. Oh, there's another way, which I will go over at the end, and that's why I picked this one, so I could specifically review this concept. Pi r squared times the height on your formula sheet. Radius for the first cylinder, 5. Height, 11.5. Good. Over here, radius. Some people would say no on this one because they use a height of 12. Remember, height is the perpendicular distance down always. All right, I know this is a little slanted. That's why I'm not counting the 12. I'm counting the 11.5. And you can just see by what you plugged in, right? It's got to be the same volume, but you can say what it actually is. You can write out the whole decimals, no big deal. Sue's correct, obviously. And why is she correct? Because they count by calculating both volumes are whatever you guys are finding right now on your calculator. Okay, I picked this one because of the different way, the other concept I wanted to go over real quick. And we did this in the volume unit. You guys probably don't remember because we probably spent about 5 minutes on it, but wanted to go over it with you. They both have the same heights. Everyone agree? If I split it horizontally, took a horizontal cross section and showed it to you, what would it be? Horizontal. It would be a circle. What would you know about those two circles and their area? They should be the same, right? Because the circles both would have a radius of 5. So if they have the same height and their cross sections have the same area, they're going to have the same volume. Anybody remember what that was called? Mathematician's name for it? Cavalari's principle. Okay, Cavalari's principle. And I'm not going to go hardcore into it. I don't want you to go hardcore into it. But if you see this on there like it did last year, and the kids are like, we never went over this, and I said, yeah, we did, because we did. All right, Cavalari's principle. Same height. All right, same height. Cross sections have the same area. Volumes must be the same. Okay, volumes are equal. Same height, same cross sections, have the same area. Volumes are equal. Okay. Just wanted to reintroduce that to everybody in case it does come up again, which it will, and when I give you the June exam. All right, let's keep going. What's up, man? We got two more. I got to get. Oh, yeah, you guys are going to hate this one. Perfect. I love it. 23. 23. You might want to have that little fact sheet right next to you for this one. Oh, this is just painful. Just reading it alone is going to be painful. Forget about how to do it. All right, circle, diameter 32. That's not too bad. Oh, the area of the sector. Anybody remember what a sector of the circle looked like? Yeah, a little shaded region, piece of pizza, piece of pie. Shaded region. I tried. I know it's not going to work, but nope, didn't think so. Here's your sector right here. It's got an area of 512 pi over 3. Perfect. What's the measure of the angle of that sector? So this angle right, yeah, that worked out well. What's the, nope, not even close. How about a blue? What's the measure of that angle right there? Whoa! Radians. Not in degrees, but radians. What's the measure of that angle? Okay, I'm going to make this easy on you so we don't have to convert. There are two formulas to find the area of a sector. One in degrees, one in radians. All right, flip through your packet for me. Because I want you, no, that's for arc length. That's good though, good. I'm glad you remembered it, but that's for arc length. S over R, theta equals S over R is for arc length. If you guys go to the page right after the circle formulas, you will see area of a sector, and then you will see sector length, which is, I think, what Will was talking about. Everybody see the two formulas for area of a sector. One is for the angle in radians, the other is for the angle in degrees. Okay? Angle in radians, angle in degrees. So this one we're going to do here, we're going to work with, which one do I want here? The top one. A equals, and I showed it to you. We never used it because you guys never wanted to deal with radians. So there you go, 1/2 r squared theta for angle, area of a sector in radians. What's the area? Okay, plug it in. 512 pi over 3 equals 1/2. What's your radius here? Be careful. Half of 32. Nice. 16 squared times theta. And that's what I'm looking for, is that angle right there, theta. All right, well, can you guys get what is 1/2 of 16 squared? $1.28? I have no idea. I did this one yesterday. I can't remember. 128? Yeah. Old guy remembers something. 128 pi. Actually, I'll write it over here. 128 theta. I know. Always catch me on that. How do you want to get rid of the 128 now to get theta by itself? I got to get rid of the 128 because I got to get theta by itself. Divide by. You could multiply by 1 over 28 too. That's fine. Divide both sides. What? 1 over 28. You could 1 over 128. You could. 2 weeks cannot come soon enough. Hold on, kiddos. Look at the multiple choice. Yes, Will, they're all in pi, terms of pi. So why am I telling you that? Don't hit the darn pi button on your calculator when you do 512 over 3 divided by 128. Don't hit because the pi is going to be in the answer already. I don't even want to mention to use your fraction templates because I'm nervous. I found out another day one of my honor students had no idea how to get a fraction template, and I just almost cried on the spot. But I can't produce tears, so that's impossible. Okay, but if I could, that's what would have happened. All right. I think it happened. I don't know, but. And they're like, no, he's good. It's going to be the story of his life. You guys getting a fraction for this one? 4/3? Can we all get that? It's just on the calculator. 4/3? Okay, and then the pi's with it. So 4/3 pi. That's why I think this exam is pretty tough because how many times do you really? Maybe once we've used that formula all year, and then they throw it on the Regents. Okay, but that's why we review it. You guys know where to go now to find it. You guys know it's got to be known along with the other formula. And then finally, I'll end today on number 21. We did this one? Oh, okay. Okay, I know what most of you guys are going to do right away. You're going to take 40 minus x and set it equal to 3x, solve for x, and yeah, that answer's up there, but it's not the right answer. Okay, when you're in a right triangle, let's try to keep stressing this over the next 2 weeks. If sine and cosine are equal, what do I always know about their angles? If sine and cosine are equal, their angles add to 90 or complementary. Yes, their angles are always complementary when sine and cosine are equal to each other. They want you to set them equal. That's why they put choice 1 there. But 40 minus x plus 3x is equal to 90, complementary. And then you guys can take it home from there. What do you mean guess and check? Well, here's the problem though. Ready? Plug in 10. You're going to get 30 and you're going to get 30. But I guess you could go. Okay, that's fine. As long as you know that concept, Cam, that's fine. But when you tell me just plug it in, like I'm saying 30 and 30, those are the same, good to go. But if you do sine of 30, cosine of 30 on your calculator, they're 2 different values. And 25. Okay. I don't think I have assigned a lot here. All right, try it out. You guys know where to get your answers, whether it be by video or JMAP. Come in with any questions you have. Topics that you want me to review real quick again, other than constructions.